Inside every plant, animal, and human cell lies billions of molecular machines made up of proteins, DNA, and other molecules. Yet, no single piece works on its own. Scientists have concluded that only by seeing how they interact together across millions of different combinations can we truly understand life's processes. There are traditional methods like X-ray crystallography and electron microscopy used to determine protein structures. However, they require many pieces of information and a longer period. Google DeepMind's newly launched AlphaFold server is the most accurate tool in the world for predicting how proteins interact with other molecules throughout the cell. It is a free platform that scientists around the world can use for non-commercial research. With just a few clicks, biologists can harness the power of AlphaFold 3 to model structures composed of proteins, DNA, RNA, and a selection of ligands, ions, and chemical modifications. Julian Bergeron, a biologist at King's College London who helped test AlphaFold 3, predicted, "Every structural biology and protein biochemistry research group in the world will immediately adopt this." So what's this mind-blowing AI model about? What's its use, and how does it benefit the science world? In this video, we will explain this remarkable innovation by Google. What is AlphaFold 3? AlphaFold 3 is a new AI model developed by Google DeepMind in conjunction with Isomorphic Laboratory. It was designed to accurately predict the structure of proteins, DNA, RNA, ligands, and interactions between all of life's molecules. AlphaFold 3 was created to transform our understanding of the biological world and drug discovery. AlphaFold 3 records a 50% improvement compared with existing prediction models like X-ray crystallography. The AI model comes with a free plan that grants access to most of its capabilities. Therefore, scientists can use the free plan to a great extent and utmost efficiency. To improve AlphaFold 3's potential for drug design, Isomorphic Labs has collaborated with pharmaceutical companies to apply it in their drug design procedures. The new model builds on the foundations of the previous model, AlphaFold 2. AlphaFold 2 was deployed in 2020. Since its introduction, it has made breakthroughs in accurate protein structure prediction. Millions of researchers globally have used AlphaFold 2 to make discoveries in malaria vaccines, cancer treatments, and enzyme designs. AlphaFold 2 has been cited more than 20,000 times in scientific journals and received recognition through many prizes, most recently the Breakthrough Prize in Life Sciences. Fast forward to the present model. AlphaFold 3 extends beyond proteins to a broader spectrum of biomolecules. Embedded within it is the potential to unlock more transformative science, from developing bio-renewable materials and more resilient crops to advancing drug design and genomics research. AlphaFold server helps scientists make novel hypotheses to test in the lab, speeding up workflows and enabling further innovation. Also, it gives researchers an accessible way to generate predictions, regardless of their access to computational resources or their expertise in machine learning. How does AlphaFold 3 reveal life's molecules? AlphaFold 3 capabilities come from its next-generation architecture and training that covers all of life's molecules. At the core of this model is an improved version of the EvoFormer module, which is a deep learning architecture that's behind AlphaFold 2's incredible performance. To start, let's say a list of molecules is fed to the AI model. After processing the inputs, AlphaFold 3 will assemble its predictions using a diffusion network, similar to those found in AI image generators. The diffusion process begins with a cloud of atoms and converges on its final and most accurate molecular structure. AlphaFold 3's predictions of molecular interactions surpass the accuracy of all existing systems. Drug discovery at Isomorphic Labs. AlphaFold 3 was used for drug design by predicting the molecules commonly used in drugs, such as ligands and antibodies, which bind to proteins to change how they interact in human health and disease. AlphaFold 3 achieved unprecedented accuracy in predicting drug-like interactions. It was 50% more accurate than the best traditional methods on the Posebusters benchmark, without needing the input of any structural information. AlphaFold 3 became the first AI system to surpass physics-based tools for biomolecular structure prediction. Laboratory experimental setup for protein structure prediction can take about the length of a PhD and cost hundreds of thousands of dollars. The previous model, AlphaFold 2, has been used to predict hundreds of millions of structures, which would have taken hundreds of millions of research years at the current rate of experimental structural biology to predict. The AI model boosts productivity. With AlphaFold server, it's not only about predicting structures, but it's about generously giving access, thus allowing researchers to ask daring questions and accelerate discoveries and advance biological science. AlphaFold 3 brings the biological world into high definition by allowing scientists to see cellular systems in all their complexity across structures, interactions, and modifications. This new invention on molecules of life reveals how molecules are all connected and helps to understand how those connections affect biological functions, such as the actions of drugs, the production of hormones, and the health-preserving process of DNA repair. AlphaFold 3 shares many capabilities with the recently published Rose TTA-fold all-atom model. Although it lacks Rose TTA-fold's ability to design new proteins, AlphaFold 3 has one big advantage, which is a new web server with a simple interface that requires no coding by the user. This enables anyone with a Google account to input the name of a protein or nucleic acid and develop predictions for the structures of the complexities it may form with other molecules. And that's it on the remarkable AI model by Google DeepMind and Isomorphic Laboratory. Do you think it is better than the traditional methods? Let us know your thoughts in the comments section. Don't forget to subscribe and like the video. To stay abreast of the latest inventions in the science world, hit the bell notification so you don't miss an update. Oh, you made it so far. Now, you understand what AlphaFold 3 is and all about how it helps biologists determine protein structure. We hope you access the AlphaFold 3 server to determine the structure of a protein. Till the next innovation and discovery, stay safe and stay curious.